Drudgery, the residents have to contend with Scotland's cold, wet weather. For 9 months of the year, these units have to be heated. That means large electricity and gas bills. The people here are poor and they struggle to afford it. So, how do you solve the problem? Well, high technology is not the answer. There's no carbon fibre, there's no microchips. Instead, there's an ingenious combination of the sun above and the air we breathe. Scientists at Edinburgh's Napier University are tapping the sun to heat houses fit for a king. A 16th century castle in the university's grounds is warming to the idea. And the solar solution is hidden in the roof. The castle's existing slate tiles act as natural receptors to trap the sun's rays. Cold external air draws heat from the sun-warmed slates and is sucked through the small gaps between them.
Well, here we have the roof of John Napier's castle. This is the south-facing slope. On the other side of that wooden material here are the slates.
Right. The warm, dry air collects in a confined space just inside the rafters and is then ducted throughout the building. Sounds simple, or is it? The efficiency of an open-loop solar air heating collector where the inlet temperature is equal to the ambient air temperature can be expressed in the form mu equals the heat removal efficiency factor times the transmissivity of any glazing times the absorbivity of absorber surfaces, divided by 1 plus the heat removal efficiency factor times the overall heat transfer coefficient, divided by 2 times the mass flow rate over the collector area times the specific thermal capacity. But is it all just a lot of hot air?
It's not a total heating system for a building, but quite a substantial proportion of the heating demand in a building, certainly in a climate like Scotland's, is for heating fresh air. So it'll handle most of that. But it would work in conjunction with the existing heating system.
The castle has recorded temperatures of up to 50 degrees Celsius, but usually maintains a comfortable 21 degrees. The beauty of this solar system is the fact that it's invisible. You don't need great panels attached to your roof. By the same token, it does make it a little difficult to show you exactly what's happening, but one way we can reveal the secrets is by thermal imaging. White signifies the hottest areas, and as you can see, heat is naturally collected on the rooftops of most buildings. But instead of being used to warm the houses below, in most cases the heat is allowed to escape into the atmosphere. But in Glasgow, residents like Kathy McCormack are putting that lost energy to good use to heat their once cold and damp housing commission estate.
In this area alone, between us, we are paying £1 million a year to heat the sky above Easter House. So we became really environmentally friendly. And the solar housing project seemed like a good long-term solution to the problem.
The houses here in East Hall have been transformed into efficient, natural heat receptors. They've adapted the techniques from the solar castle, ducting warm air from the roof into the rest of the house.
Next stage, because the whole purpose of this is to preheat water, is to go through an air-to-water heat exchanger. Right. That's in the box.
And they've installed other active and passive solar energy features, like rooftop panels for hot water, double glazed windows, external insulation, and a design that takes full advantage of whatever sunshine they get.
The secret of this space is it's not heated, so it's acting as a kind of climatic buffer between the heated part of the house and the outside.
And the heat escaping from the warm part is recycled here?
Yes, it is, especially in the winter. This space is being heated up by the heat lost from the house. And we can then recycle the heat by means of air moving in through these slot ventilators. If this door is closed or if the door's ajar, just straight through here. If it's in the depths of winter outside, it might be autumn or spring in here, and we want it to be summer inside the bedroom and inside the living room.
This means Frank at number 16 can stay warm for less.
It used to cost us in the damp house £20 a week for electric, and now it's costing us £5 per week. Now what a difference.
These simple solar initiatives have dramatically improved the quality of life for residents at East Hall, and the hope now is for that little ray of sunshine to warm the lives of many more.
Coming up next on Beyond 2000, tracking the mysterious lights that dance above the storm clouds.
But they were bright and they were red. They were spectacular.